morning, everyone. Yes. So I have an interesting and good question in the chat with respect to the upcoming midterm. Are there any problems that you would recommend us do? Well, if you take a look under week 4, midterm 1, there is, in fact, a practice test 1 _ master sheet of problems. This is kind of in the form that I would normally give a test if it were a paper test, you know, with enter your name here, etc. But if you take a look through this document, there are a bunch of questions that are hypothetically designed in such a manner that you would be able to do these questions, see something like these questions on the test that's coming up, that is. So that's sort of, if you're looking for some extra practice material, that's a good place to look first. And there's also this reference sheet, which I think is pretty useful. Normally, this is the crib sheet that's given out during a test. Again, that we would do in person. But since we're not, and you have the Python, python.org as reference, that might be more useful to you. But, I think it's still useful to have a cheat sheet or like a quick reference type document as opposed to having to search everything. So if you're interested in pulling that up while the test is actually going on, it's available from the Avenue page as well. If you take a look under Extra Resources, you will find the syntax reference sheet there. Furthermore, if you feel that the questions that have been provided in the practice test are not sufficient for your purposes, there are a bunch of links here which are also good ones. I would especially recommend CodingBat. CodingBat is a form somewhat similar to JupyterHub in that you enter a program and then it tells you how you did when you press a button. So, for example, parrot trouble. It gives you a problem here. You write your function and then it kind of, compiles it for you and tells you where you did wrong, which is very useful, I think. So those are some extra resources I would recommend if you would like some study material for the test that's coming up at the end of this week. When is the test? That's also a good question. These are very good questions. The test begins at 9 a.m. this Saturday and goes until 9 a.m. the following Sunday. So you've got a 24-hour period in which to complete the test. The test is considered... Oh, did I not modify the... Oops. That's from... Never mind. I'll just... Thank you. That's from the other class. The other class is a class in C programming. No, we're not actually doing C today. Sorry about that, guys. Yeah. So it starts 9 a.m. Saturday, goes the whole day Saturday until 9 a.m. Sunday, and that's how long you have the right to write the test. The format of the test will be JupyterHub. It'll be a JupyterHub notebook in the same way as the assignments. The test is not proctored. We are can you imagine proctoring a test for 24 hours? Good Lord. No, the test is not proctored. This test is going to be performed under the auspices of the take-home test. We are considering it an open book take-home test. So take from that what you will. Be advised that we are going to be checking your we are going to be checking your tests after collection for academic dishonesty using automatic software. So don't cheat. If you cheat, we'll catch you. Will the questions be similar to CodingBat/assignment questions? They'll be more similar to assignment questions than CodingBat. I find CodingBat, the questions are a little bit on the easy side, any particular one of them. They sort of do the quantity over quality thing, but that's still a good resource. So they'll be closer to the assignment questions. So the format, again, will be exactly the same as on Jupyter, or on the assignments on Jupyter. Is it hard? You'll just have to wait and find out. Will the test be available on Avenue to Learn? Yes, it'll be distributed through all of the usual channels. Will the test be as long as the assignment? No. No, I don't think so. So you have 24 hours to do it. How long is the test? Generally speaking, my sweet spot for the test is that it should take you about 2 hours. That being said, it's, mileage may vary. Generally speaking, in the past, when I've said, oh, this test should take you 2 hours, when people have, a full day to do it, generally speaking, they take longer to do it. And I think that's kind of a combination of the fact that you do not have, a specific, 2-hour time limit that you're staring down the barrel of, so you're kind of well, I can take as much time as I need to, so I'm going to. But also, some people, the degree of programming skill that you've acquired so far will translate directly into how long it takes you to write the test. So if the test, it is entirely possible, and this has happened in the past, that some people might take what might be considered an inordinate amount of time to write the test. If you're taking 8 to 10 hours to write the test, I would say probably you should have studied. However, it's still possible to take 8 to 10 hours to write the test if you wish. So there you go. When do you get your assignment marks? We'll have those marked, hopefully, and back out by Wednesday. Yeah. Which material is covered? So, hypothetically, the stuff that's covered is up to the end of the slide set that we're currently on. So, I think it's a little bit cruel to test people on the material from the week that we are doing stuff in. So, you can expect things to be covered up to the end of Topic 3 statements, which is a thing that we are, going to be hopefully finishing off today. There we go. Can you use commands that weren't taught in the tutorials? Yes. Generally speaking, we are not going to cause... the idea is not to limit you guys unnecessarily when it comes to Python. If you think about programming constructs as tools in your toolbox, I'm not going to say, no, you can't use a pair of pliers because we haven't done pliers yet, But, yeah. Can we also access the test through Jupyter Hub like the assignment? Yes. Yeah, you can access it through either avenue and do it on your local Jupyter installation, or you can do it all through Jupyter Hub, the same way as the assignments. Is Googling considered cheating? Well, it depends. So, using the Python documentation, I do not consider that cheating. It is an open book test. I also would not consider using sources like Wikipedia to be cheating. I would consider sharing code with other people who are writing the test or taking code from people who have posted the solutions to the test questions. If you can find, like, the internet's a big place, right? It's entirely possible that someone has put the questions that we're about to ask you guys up there already, despite our best efforts to be original. So if you are copying stuff from the internet, that's academic dishonesty. However, if you're using the internet as reference material, so, using Wikipedia and the Python documentation, stuff like that, yeah, python.org is the Python documentation, then that's all fair game as far as I'm concerned. So there you go. How fast is the test possible to be done? I don't know. I could probably, if you were really good at Python, you could probably crack the thing off in, 30 minutes, I'd say. But, anyway, I think that's enough talking about the test. Why don't we get to our actual lecture material for today? I'm sure people will have more questions. Yeah, Jupyter Notebook is the file. Jupyter Hub is the environment in which the file exists. So when I say the test is a Jupyter Notebook, what I mean to say is it's a .ipynb file inside of Jupyter Hub, or that you download separately. So anyway, if I remember correctly, we were in the middle of talking about Spectre. So I'm kind of actually inclined to skip the rest of it, but we can go through it quickly. So don't worry, Spectre isn't going to be on the test. So in general, the thing that's going on with the Spectre bug, Spectre was a security vulnerability that was affecting a large number of Intel and AMD CPUs a number of years ago. And essentially, the problem was that these CPUs, which had multiple cores, were doing branch prediction on if statements. So if you have an upcoming if statement, the computer would look ahead in the program and try to pre-compute some of the results of if statements, while some other, like if it's hung up with some function, it'll try to do the stuff that's after the function. And if it's correct about its prediction, you've sped up the computer. If it's incorrect about its prediction, you haven't slowed down the computer, versus like what a linear execution would be. The problem, however, was that essentially you've got well, the problem gets into the architecture of the computer itself. So within the memory unit, you've got two main sections of memory. You've got the main memory and you've got cache memory. Cache memory is a faster memory that is used for values that change frequently. It's data can be loaded from cache more quickly than from main memory, and that's why it's used for, these very quick operations. Things that take, if you only need memory for, a few microseconds or something like that, then you would store it in cache memory. Save cache recently used values in the cache, so if we try to use them again, we can get them faster than loading from main memory. Yeah, so what was going on with Spectre is the results of these branch predictions was being stored in cache memory. The problem so we're not quite to the problem yet. If branch prediction was wrong, then the CPU resets all of the variables and then runs the other branch and continues as normal. But resetting after branch prediction doesn't reset the cache. So essentially what happened was these branches were being predictively executed and the results stored in cache, but the cache memory wasn't being cleared if the branch came out to be wrong. So the data that was loaded during a wrong branch prediction was persisting longer than it should have been. And this turned out to be an exploit. If you got the timing right, you could actually load the data that was stored in the cache from this incorrect branch prediction into a program that wasn't even the program that originated the data. And this is a problem because, when you're talking about information security, you have to work under the assumption that the data could be someone's password, it could be someone's credit card number, it could be, sensitive data that actually matters to real people. So because these predicted branches were being stored in the cache and not being deleted when the branch prediction turned out to be false, they could be accessed by an attacker program. And that's essentially what the Spectre bug was all about. Looking at some questions. Is RAM and ROM considered cache memory? ROM is certainly not considered cache memory. So it depends on the particular system's architecture. My general impression is that cache memory is generally kept as like onboard flash memory inside the CPU these days. I could be wrong about that, but like your RAM is like your RAM chips. You buy a stick of RAM, stick it in your computer, download some RAM from the internet. Asterisk, that doesn't actually work. But ROM is your magnetic disk or your solid state drive, and those are the slowest. Those are your permanent memory. We are definitely talking about random access memory when we are talking about cache, because the cache is not persistent across power cycles. But there you go. Yeah. So someone is asking me if I'm going to ask theoretical questions on the test. Generally speaking, things will angle more towards practical problems. So you should learn how to program for the test. Yeah. Certain levels of cache might as well be RAM. Yeah, the thing about... So, in general, computers are among the most complicated things, the most complicated single entities that human beings have brought into existence. The only thing more complicated than a single computer would be something like the economy of a nation, or something like on that type of macro scale. Like the number of ways in which computers are organized is highly diverse, and the organizations, like you could spend your entire university degree just studying a CPU, like one CPU. However, that might not be the best use of our time, considering it is our objective to learn how to use computers pragmatically as tools. It's important to know a certain amount of this kind of stuff, but this is why we speak in these types of generalities. It's important to know that cache exists, but with respect to where it's stored and that sort of thing, that is a low enough detail that it doesn't really matter most of the time, and you don't need to know how memory is stored in terms of hardware necessarily in order to access it. What you need, or in order to use it effectively, what you need to know is the general principles upon which memory works. And if you're more interested in how memory works, then I would recommend taking a course in C sometime, because programming in C, you have to know how the memory works, or else you're not a good C programmer. But anyway, so let's talk about a quick algorithm. Let's talk about linear search. So the idea with linear search is that we have a sequence of values, and we want to find the first occurrence of a specified value. So for example, if you wanted to find the location of a character in a string, there is a function for this, but one of the tasks that we often put before ourselves when we are trying to learn how algorithms work is, rather than just refer to the library function for each of these functionalities, how would we go about implementing such a thing ourselves? So, rather than here's a candidate solution. Define linear search 1, takes a string and a character. I is equal to 0, while I is less than the length of s, and s at I does not equal the character, I plus equals 1. If I is less than length of s, return I, otherwise return false. So we could come up with a slightly better version of that. Oh, here's a Python interpreter from previously. So if we wanted to do something like that, we could say, for example, well, the easiest thing to do, like the sort of smart Alex way of doing it, would be to return C in S. But, we're trying to actually see how in works, right? So I is equal to 0, while I is less than the length of s, if s at I is equal to C, return true. Or it wants the position, so return I. Exit the if statement, and at the level of the while loop, once the while loop has finished, if we have at no point returned the value I, then we return false. So, if we have a linear search of, for example, hello world, and we are looking for the character H, that is at position 0. And O, interesting. Oh yeah, I forgot to increment the thing. Ha ha ha. Okay. Well, anyway, you get the idea. One should not be a silly person and forget to increment I, as I did. Otherwise, you run into exactly the thing. Yes, I know. My goodness. She's around here somewhere. Will we be learning about debugging in this course? Yeah, we have a certain amount on testing and exceptions that will happen after the break. We have a topic on that subject. Yeah. Oh, she's over there. She definitely likes to command the attention of the room, that's for sure. What's her numbers like? 150. If she comes within grabbing distance, I'll grab her. Okay. So, another variation on this, which is the one that I was attempting to show you, is to return I immediately. So this one waits, basically this one executes the entire loop until it hits SI being equal to the character, and then it exits the loop, and then has a post condition. It branches after the loop to determine whether or not I reached the end of the loop. If it reached the end of the loop without, breaking earlier, then we return I. This one just returns I immediately. Frankly, I think this is a little bit nicer. I'm not a huge fan of the having the if statement afterwards. I think it's semantically a little more confusing, but, it is what it is. So break statements. Break statements are a new construct for us. You can use the break keyword to stop the execution of a loop and jump to the next statement after the end of the loop. So if under certain circumstances you want to just quit the loop, you can use a break statement. So for example, while I is less than the length of s, if s at I is equal to c, break. Once this condition becomes true and that break statement executes, control is immediately passed to this statement. It immediately is broken out of the loop. It's like the loop condition came out false, but in the middle of loop execution. So let me see if we've got any questions. Shouldn't it be length s minus 1? Good question. Let's see. Well, it's less than, not less than or equals. If it was less than equals, then it would be length of s minus 1. Because, of course, everything is 0 indexed. But because we're using less than instead of less than equals, but then we use the length, not length minus 1. Good question. Good question. Doesn't it return false even if you find it? No. If you find it, then this will come out true, which means we'll return on I. If we do not, if we never hit this break statement, then I will have reached the value of length of s, right? This will be broken when I is equal to the length of s, in which case this will come out false, in which case we will return false. So let's talk about for loops. For loops are another type of data loop structure which iterates over all of the elements of a data collection. So when you're trying to do numerical stuff, it's sometimes better to be using a while loop, especially if your condition for the while loop is, somewhat unorthodox. For example, I've seen programs where the user is prompted for input, and as long as the user has not entered, correct or expected input, they are stuck inside of a loop, and it's, the user's input being correct or type correct that, causes them to exit that while loop. That's not something you can do with a for loop. However, for loops can be used for all kinds of other things. For loops are, generally speaking, a little bit safer to use because they do not require you to index an element. You know how I caused myself an infinite loop by forgetting to increment my index here? In a for loop, that's not possible. There is no index in a for loop, so there's no index to forget to increment. So, yeah. Unlike while loops, the number of iterations in a for loop is always bound, so they hypothetically cannot get into infinite loops. If anybody in chat can think of a way that a for loop could be made, if you already know what a for loop is in Python, if you can think of a way to get a for loop into an infinite loop, please provide your answers in the chat now. So, good question. Okay, I thought functions can only return one type. In other programming languages, that is the case, but since Python is dynamically typed, you can have a function that returns multiple different kinds of things, depending on its execution path. That's an element of Python's, dynamic type system. There you go. Why do we need the second statement if we use break? You kind of don't. I mean, you could also just use So, all of these people who have ideas about how you might do it. Ah, there we go. Someone's got it. For I in C, append something to C. Yes, that's correct. That's the correct one. So, because for loops are bound to the data structure that's specified in them, if you increase the size of the data structure as you are looping through the data structure, basically the data structure, if the data structure is growing faster or at the same rate as it's being executed through or it's being iterated through, then that's an infinite loop for loops. So good job. So let's compare syntactically what a for loop looks like versus a while loop. And I highly recommend getting to know for loops because they are a faster and easier way of doing most things. So if we wish to print each character in a string, the string is potato, I is equal to 0, while I is less than the length of s, character is equal to s at I, print character, I is plus equal to 1. In a for loop, all of these things are implicit, or 3 of these statements are implicit. We still have to specify that s is equal to potato. However, we type for c in s, print c. So we specify s. We specify s as the data collection that we are iterating over. So, yeah, and we designate the variable name c to mean each character in s. For each character c in the string s, print the character. So this assignment statement is implicit in our designation of c here. So the index, and you'll notice that the indexing variable does not even exist at all in the for loop version. So I is done, doesn't need to be incremented. C is automatically assigned to each of the elements of S in succession. So C, the first iteration of C would be the P, then the O, then the T, A, T, and O. So that's how a for loop works, essentially. Let me see if we have any questions. Yes, you should think in Python, not Java. So, the body of the for loop should not modify the variable, or you can get into infinite loops or strange behavior. So, again, if S were being modified inside of the body of the for loop, that might cause you problems. Whoop, jeez. I hate clicking on the bar. Okay, there we go. So, if we wish to iterate over a range of numbers, this is going to be the introduction of the range function in Python. So, if you want to generate a range of numbers, say the numbers from 0 to 30, then that function produces an object. It technically produces a range object, but you can see what's going on there if you cast it as a tuple. It generates a list of numbers from 0 to 1 minus 30. But the number of numbers in there is 30. And just like list slicing, if you wish to specify a beginning number, then that would be the first argument, and the ending 1 plus the ending number would be the second argument. And if you wish to count by a certain number, you would specify that as the third argument. So that's how you use. Using the way that you use range is very similar to how you would do list slicing or tuple slicing. Anyway, so in this case, if we wish to print all of the numbers from 0 to 10, or 0 to 9, we would set I as 0, n as 10, while I is less than 10, print I plus equals 1. In the case of the for loop, you would say n is equal to 10. For I in range of n, print I. So that's easy enough to do. For I in range 10, print I. And there you go. Easy peasy. So you can see how this would replace a reasonable amount of what we would use a while loop for. How do you prevent other programs from reading cache memory? Well, it's good practice to deallocate any memory that you've allocated. But generally speaking, that's not your problem, that's the operating system's problem. Are you allowed to import libraries for the tests and the assignments? Yes, of course. In fact, I would say it's required. Can you change the amount that I increments by, so have it go up by 2 or 3? Oh, yes, of course. Yeah, absolutely. All you would have to do is just modify this 1 into a 2 or a 3. Yeah, in fact, you could... One of the things about the while loop that gives it, like the only advantage of the while loop over the for loop is the adaptability of the condition. You can make the condition anything that you can express mathematically, whereas for loops are locked into more rigid constructions, although those constructions are more commonly used. So, yeah, I mean, if you wanted to have, I start at 256 and be divided by 2 each loop iteration until it reaches 1 and then exit, then yeah, you would do that. You would just say I equals 256 and I equals I divided by 2 each time. And then, if while I is not equal to 1 or something like that. You can do all kinds of stuff. Anything your heart can imagine as long as it can be expressed in mathematics. So, yes. So the body of the for loop should not modify the variable n. Yes. The loop variable I is undefined after the loop, and that's not actually true. You can actually access the loop variable afterwards. So that's not true, but that's okay. Perhaps it says it's not a good idea. Perhaps it should say it's not a good idea to access your loop variable afterwards, but, maybe it could be. So, as I said, the range object, it looks like a function, but it's actually the initializer for a class. We're not going to talk about classes until week 8. But just keep in mind that there's slightly more complicated things going on than it just being a function. It's sufficient to think of it as a function right now, though. There are 3 ways in which range can be used. Again, if you specify one argument, you get a range from 0 to n minus 1. If you specify two arguments a and b, you get a range from a to b minus 1. And if you specify a, b, and step, then you get a range from a to b, counting by step. Interestingly, b is not necessarily included in that. If you take a look at the range that we generated here, notice that in this case b minus 1 would be 29, but 29 would violate our counting by 2 rule. So we stop at the largest number that's still inside of the range that we want. Cool. So the arguments to the range object must be integers, and you can convert the range object to a tuple by casting it, as I showed you. You can also convert it to a list, if you like. Lists are a dynamic data structure, and tuples are a static data structure. So depending on whether you need stasis or dynamism, you can cast it to whichever one of those you prefer. So, printing a list of even numbers, there we go. We can, of course, for loop that. For x in range from 0 to 50, counting by 2, print x. You notice my printf reflex? In C, the print function has an f on it, and like the amount of programming I've been doing in C lately, man, when you know multiple languages that are like very similar but like just slightly off in terms of their syntax, it can be really annoying. But anyway, you can see we have counted. We have every even number from 0 to 1 minus 50. So, linear search using for, with for using range. So, if we go back to our linear search, you can see that this while loop is a good candidate for replacement with a for loop using range, because we have an index variable that's being incremented. So, for I in range length of s, if s at I is equal to c, return I, else return false, or, and if that doesn't work, return false. You can simplify that even further. Def lin search 5, let's say, for c and s, for c2 in s, if c is equal to c2. Oh, yeah, oh, no, I'm sorry. Yeah, the problem with that is if you're interested in getting the index as the return value, the way that I'm going about it right here, that would return like a true or a false. If it's like a test for presence. In that case, I would be replicating the in operator. But if you actually need to know what the index is, then you would have to use the range object, trace through it by index, because then you would be able to expose the index back to the program that was calling the function. Yup. Burp. Let's see. Questions? When we stared at Python, I had so many printf errors. Yeah. Ugh. Yeah, you don't have to know what a Java loop is. Don't worry about it. Don't worry about Java. Don't worry about Java. We're not learning Java. We are learning Python. This is a Python class. There you go. What is the difference between lists and tuples? Oh, we are totally going to talk about that in much depth in topic 4, but essentially it has to do with the way in which memory is allocated. Um, lists also accept multiple types in Python, just so you know. So range 0 to 100 by 5 starts at 0, stops at, and doesn't include 100, and 5 is how much you increase by every time. Yes! Yes, yes, yes! Paul, you understand. Yes. So why is the else statement indented right below the if statement? Is it? Oh, no, this isn't an else. In order for it to be an else, you have to have the else keyword. No, this is do this after the for loop. So the idea is return will stop a function. If a function hits a return statement, it returns the value in the return statement and terminates the function. The function is closed. It is not open for business anymore. It has performed its function, so to speak. So if you hit any return statement inside this loop, this one will not be reached. However, if you go through this entire loop without hitting this one, then you would hit this one and return false. Hopefully that's okay. Are you going to learn other search algorithms in this course? Yes, absolutely. We're actually going to do there's a reasonably heavy example on binary search that's, I believe, coming up in the next set of lecture slides. So that's cool. We will be doing lots of searching with the binary search algorithm. Are assignments tougher than exams? You're just going to have to find out. I would say the assignments are generally longer than the tests would be, but the questions tend to be around the same. Is it possible to take the range to infinity? No. Neither practically nor theoretically. In order to, you can't... I could be wrong about this. There's probably some library that adds in support for it, but as far as I know, Python does not support infinite data structures. Haskell, incidentally, does support infinite data structures, and that's actually how they manage to be Turing complete, but that's a whole nother discussion. What other courses do I teach? I'm also teaching Software Engineering 2 MP3 Programming for Mechatronics, which is a C programming course for the Tron guys. Since our algorithms course is in second year, how should we prepare for co-ops this summer? Do you learn enough in this course? Blur. This is not an algorithms course. I would say take it one step at a time. You gotta learn some stuff before you get to algorithms proper. In order to know algorithms proper, get into algorithms properly, you need to at least have some object-oriented stuff under your belt. Give it time. You're gonna get there. But no, I wouldn't say that this course is going to give you enough. There are some very Can I show you how to infinitely loop the loop? Sure. That would be super easy. So here's how you could create an infinite loop using a for loop. Let's say we have L is a list 1, 2, 3. For element in list is equal to list concatenated with the element. Oh, okay. Oh, interesting. That didn't actually infinitely loop. Maybe it would work. I don't know. We'll see. Is class over? Yeah, class is over. I have, just a few more slides, but too many to cover in the next 30 seconds, so I think we'll call class over. I'll stick around in the stream a little bit longer to answer any questions, but otherwise, we can, get going. Actually, I have a bit of a question for you guys, for anybody who has the time to answer it. And, maybe we can, start a discussion. So I've been this weekend I was sort of plugged into. I don't know where Rimby is. Rimby, kitten, where are you? She must be in the other room. It's come to my attention over the course of the weekend that there have been some, shall we say, there's been feedback coming in through various channels that the way that courses are being performed. You can't. Pardon me, but which cat is your favorite? You can't have a favorite cat. That's like having a favorite son or daughter. That's just crazy talk, man. There's been some feedback coming back to the through various channels that lectures aren't necessarily going smoothly. Some profs are apparently taking too much time. There seems to be some classes are having synchronous and asynchronous lectures. This would be a synchronous lecture because you guys are actually you guys are in the chat and we're talking. I would be interested in any feedback that you guys have about the structure of this class so far. If this class has been one of the better classes, if there's something that if there's something that some other prof is doing that is really nice, please let me know. I'll see if I can integrate the way that people are the best practices from other classes. I would be interested in integrating those. Yeah. Okay. So Nishit seems to think that this is a good way of doing it. Okay, so this is good. If you would like to provide that sort of feedback anonymously, then please send me an email as well. Okay. Okay. Oh my goodness, there's so much feedback, you guys! This is amazing! So I've... Okay. Well, see, one of the things that I like about having the lectures up on YouTube as well as having them run, it allows me to sort of be both synchronous and asynchronous without having to create any extra work for you guys. So, if somebody wants to take this class asynchronously, then I'm not standing in their way. The only thing they're losing is the ability to ask questions, which you would, hopefully Piazza is making up for that. But, yeah, okay. Thank you, guys. Thank you so much for the feedback. Okay. Yeah, generally speaking, the design philosophy I took was to try to simulate the experience that you would have with in-person classes as much as that's possible. But okay, okay. With respect to moving to Teams, um, I don't know. More people would have to be asking for that. If you'll forgive me, Nishit, you seem to be the only person at the moment asking for that. But um, hmm. Yeah, and the other thing is with YouTube live stream, you can actually run the lecture back while you're watching a synchronous lecture, which is kind of cool. Um, hmm. Okay. Okay, so a couple of people want Teams. Hmm. Okay. Ah. Yeah, the one thing about YouTube is like there's like a 30-second delay between me speaking and you hearing what I'm saying, but yeah. Part of the problem that I have with Teams is that it's like um the requirements on your guys' part for internet connection are a lot more stiff. And like I've been on video conference calls on Teams before, and I find the audio quality is like super terrible at times. And like if you're listening to me for a long period of time, I feel like you guys deserve good audio quality, even if the video quality is kind of, sometimes a little. Yeah. Mm. Okay. Host discussion sessions. Something like an office hours. Yeah. Hmm. Set up a chat on Teams. Yeah. Like in theory, the purpose of Piazza is to get you guys to have constant access to the TAs. But if you guys feel like, maybe what we could do is we could do like office hours on Teams, and that would like plug the gap that people seem to have. But yeah, yeah, maybe if I held out, yeah, okay. Nicholas, we are of one mind. Okay. Will there be a midterm review session? Yeah, that's not a bad idea. Hmm. Okay. Thank you guys so much for all of this feedback. This is really, really useful. Um, cool. Will the test be similar to assignment 2? It'll be more similar to assignment 1, to be honest with you, because assignment 2 starts to get into the data structure stuff that we are supposed to be covering this week. I think. Am I thinking? No. No, that's assignment 3. Pardon me. No, yeah, so assignment 2, you'll probably see reasonably similar stuff, I think. Um, hmm. YouTube is working better than any other channels for us who are using VPN. Okay. Okay. Yeah, I think. Yeah. Okay. So the problem with Zoom is that they want money for it, and I don't. I'm poor, so I'm not going to pay. And I'm also not going to build a department for it when they've already spent a lot of money, laid out a lot of money for Teams, and it does basically the same thing. Sorry guys, if you're like late for your next class because of this discussion, but I think it's important to have this conversation, and I couldn't think of a better time to have it than when I have you all, guys all here. You know. Um, I don't know what a MOOC is. Yeah. Can I use touchscreen? I don't. Maybe. Maybe I could see if I could get some sort of draw on the screen something, because, like, I don't know, like, I've been just kind of highlighting text with my cursor, and that's probably less efficient than being able to draw on the screen. Like, I have a little drawing tablet. I might be able to hook something up. But, okay. So, to the question, is it a problem if I don't understand a lot of the methods I'm showing for a specific code? No, it's not. It's not. If you're having a little bit of difficulty following what I'm doing in lecture, that's not necessarily a bad thing. I find not as like fewer people learn by hearing me speak as learn by doing the assignments. If you've gotten through the entire assignment and you still have difficulty with the concepts, then I would say that's probably the point at which you should be seeking help. But consider, don't panic yet if you don't get the stuff, because it's when you put it into application that a lot of the stuff is going to click. So don't worry. Don't be so hard on yourself. But yeah. Are they already paying for Zoom? Well, there you go. I like how objectively marked the course is. Well, thank you. I find actually with auto grading that there are fewer people, there are fewer like requests for remarking and stuff like that. You know, human error is, a thing, and generally speaking, if I can take TA resources and put them to something that benefits you guys more directly, then I think that's useful. But anyway, I think that seems like the chat seems to be slowing down. So yeah. So I think the big takeaways are, you guys seem to want to have a office hours set up on Microsoft Teams, and I think that seems to me to be a good idea. So I'll probably do that. I'll make an announcement about when I will schedule that on Avenue sometime this week. And aside from that, yeah, I think you guys seem to like the way things are going, so we'll just keep going that way. But okay, is it possible that this problem be brought to the other professor's view? Yes. So, Mr. or Mrs. Juicy, can you be specific about which problem you're referring to? Could you say which problem you're specifically referring to there? Because I've kind of lost the thread with all of the chat discussion. But yeah. Well, as it happens, Your poor humble professor is the I am the I am one of the PhD students of the head of the department, so I can actually I have a channel to, raise things with people reasonably high up in the department. And yeah. Okay, so yeah, actually this the async versus like doing both synchronous and asynchronous, um the department is aware of the problem. Um, there hasn't been like an official edict that's come down from the department to stop doing it. However, that the department's aware that it's a problem, and there has professors have at this point been requested to stick to their times. So, yeah. Yeah, I'm not sure why this developed in the first place. It doesn't really make sense to me that, because things are online, you guys have twice the time to attend lectures. Like, 1JC3, you say. Is that Dr. Farmer? I think that's Dr. Farmer, isn't it? 1ZA3. Okay. Well, okay. Yeah, I will, when I have my meeting with Dr. Lawford this week, okay. I'll pass along some of these concerns. Particularly, it seems the synchronous and asynchronous thing is just killing you guys, so. Well, I'm pretty sure that I can't do anything about 1JC3 having participation marks. Okay. Cool. And you guys, I'm quite certain that if you guys had a problem, then with me and the way that I'm doing things, you would have told me, because yeah. Okay. I will pass these concerns along. It's sort of it's highly outside of the ability of me to do anything about it in concrete terms, because it's it's not really my purview. It's not really my it's more than my job's worth. It's more than my job's worth as a sessional to tell tenured professors how to run their courses. But yeah, I'll bring your concerns up with the department head this week. But yeah, anyway. Yeah, that's the other thing is I think up to a week or two ago, everybody was like, "Yay, this is fine," and then the realization set in that we're staring down the barrel of 8 months of this. So, yeah, well, you're welcome. This is, oh my goodness, I got a. So, I hope you guys can forgive me, but I was creeping the Discord a little bit for the computer science Discord, and there was this one guy who linked to a Reddit post of this guy who's talking about how this semester is turning him into an alcoholic, and how his life has significantly become less good, because of the online nature of things, and how everything is just shit right now. And I want to make sure that I am not contributing to that problem, insofar as I know that every course contributes to the workload, but like if we can get this semester through with, you know, the minimal amount of heartache possible, I would say that that would be a good thing. Yeah. But anyway, so I guess if you guys did have a class after this, you're 10 minutes late for that class, so I should probably let you guys go, but yeah. Keep up the good work, folks. Stay strong. We're going to get through this. We're going to get through this together. And we're going to learn programming while we're at it. So, yeah. Anyway, take her easy, folks. And have a good rest of your Monday.